Hello and welcome to this video on the TCP three-way handshake. In this video, the topics I'm going to cover is the purpose of the three-way handshake. I'm going to define things called TCBs and sockets. We're going to look at the difference between TCP active opens and TCP passive opens. We're going to look at what specifically within the TCP header is used to work with a three-way handshake. And I'm going to do an animation of how TCP connections are created. So, the TCP three-way handshake, what is its purpose? So if you've been watching any of my videos on TCP or you've learned about TCP elsewhere, you've probably learned that one of the big differentiators of TCP versus UDP is that TCP is what's called connection-oriented. And one of the things that I stress when I stress what that means is that TCP, before it sends any data to a destination, first validates, is that destination alive? Is he actually there? If the destination is there, then he says, okay, let me negotiate some parameters with you up front that's going to control the flow of the sequence of data we're going to exchange back and forth. The TCP three-way handshake is the critical component in doing all of that. So it starts the process of opening a connection. It proves the existence of the destination. It establishes what the initial sequence numbers are going to be for TCP segments. And there's an exchange of parameters that takes place. Now, in order to understand the TCP three-way handshake, we have to understand some terminology first. This terminology of TCBs and sockets. So what is a TCB? It stands for a transmission control block. Transmission control block. And like this says here, this is a block of memory space allocated by a CPU to maintain state information for a single TCP session. Now, in that TCP, in that TCB, that transmission control block, a big part of it is TCP socket information. Okay, so what is in a transmission control block? Well, if I was to draw it here, just to give you sort of a conceptual idea, let's say that you are your source, so you, the source, are 1.1.1.1, and you just opened up a web browser. So that's going to be HTTP, and you're going to be going to a destination of 2222. Well, a transmission control block is going to be created for that. So for example, part of that transmission control block is going to be your IP information. 1111 is going to be you. You're going to be going to 2222. Okay? Another part of that transmission control block is going to be the destination port number you're going to use, which in this case, if you're doing HTTP, is going to be port number 80. You're going to come up with a random source port number to keep track of this individual session of information, which might be 51002. So that's going to be in there. You're also going to have, as data is coming in and going out, that data is going to be stored in memory. Okay, maybe for this particular session, memory cell location number A all the way through memory cell location number Z is where all that memory is going to be stored. So that's also going to be here in this transmission control block. We'll just say memory location A through Z. That's going to be where all the information is actually stored. And a lot of other stuff. Your sliding window mechanism, bytes received, bytes transmitted. Everything TCP needs to keep track of the session and the flow of the session and what's currently outstanding, what currently needs to be acknowledged, all of that will be kept here inside this transmission control block. So, how is this created? How's a transmission control block created? Well, I just showed you one way. One way is where you decide you're going to start up HTTP. You pulled open a web browser. You pulled open a web page. There's two ways this could happen. So one way is what's called an active open. And that's what I just drew. And we'll look at that again on the next slide. And there's also something called passive opens. So just to recap what I just talked about, TCP active opens, this happens on you, your TCP client, your smartphone, your tablet, your laptop. The moment you open up an application, the moment you open up a new browser in your web browser, anything that uses TCP that you just started is going to open up a transmission control block. And this is that transmission control block is not going to be created until you start the application request. So that's why we call it an active open. You had to actively do something to get TCP to recognize, oh, I should probably create a TCB. Then, once your transmission control block is created, now you can send out your TCP SYN. Keith, what's a TCP SYN? Oh, we'll get there. That's coming up. But just be aware that you can't send out anything related to TCP until your transmission control block is sitting there ready and waiting to go. By the way, on the slide it says ISN. That stands for initial sequence number. The initial sequence number that you're going to be putting in your very first TCP segment. Now what about the other side? The TCP server. So you've got your TCP server sitting out there and they're recognizing in advance certain things. So for example, if I have a web server, okay, if I have a Linux or an Ubuntu server or something like that, and it's running Apache or some web server application, I'm going to put my files in there, my graphics, whatever my web page content is, and then I'm going to basically turn on the web service in that server. Now that server's not sending anything out. By turning on the web service, I'm basically turning on his listening ability to listen to incoming TCP requests. So he is creating what's called a passive connection, or what's called a passive open. So he's going to create a transmission control block, just like I sort of drew, but some of the elements in there are going to be undefined. For example, in that block, he's going to put down his own IP address, but the IP address of the other end of the session, well, that hasn't happened yet. So that's going to be empty. That's waiting to be filled in by some client saying, hey, I'd like to talk to you. The port numbers. Well, if we're talking about, I just started up the HTTP service in that server, he will create the port number of 80. He's listening on that. But what's the port number coming in? He doesn't know yet. He's passively waiting to find that out. So that's what a passive open is all about. All right, so let's see. How does TCP initiate a connection? You may have heard of the TCP three-way handshake. What exactly is happening there? And in order to do that, we're going to be focusing primarily on the control flags field inside the TCP header. Okay, so number one, a transmission control block is created as a result of a passive open on the receiver. Like I said, the receiver is, for example, your web server. You just went in there and you activated the web application. He's now listening. He has just created a passive open. Now he sits there for minutes or hours or days until somebody needs to use him. Now, a few miles or thousands of miles away, somebody opens up their client and they create an active open. They open up their web browser and they type in google.com or something like that. That creates a transmission control block on them, which is considered an active open. So what are they going to do? Well, they're going to send a TCP message from sender to receiver. Now here's the thing. When you open up your web browser, most likely, like 99% of us, it defaults to some home page, right? Whatever your home page is. Hopefully your home page is INE.com. If it's not, change it there right now. But let's say your home page is not INE.com. Let's say it's Google as an example. Typical home page. All right, so here you go. You just open up your browser. You open up a tab in your browser, go into Google, all right, with a little box where you can type in, please give me INE. Okay, so, but in order to display that, okay, now to you it looks like, oh, there it is, it displayed it. But things had to happen in the background to see that Google tab in the first place. So what had to happen is the HTTP process had to start up. It had to create an HTTP GET request or GET message, which basically was a message saying, hey, google.com, I'm trying to get your homepage. I'm trying to get that. So that's what the application creates. Then HTTP says, hey, TCP, I need you. I need to use your services. So that's when this happened, the active open, and we created a transmission control block with all those fields I talked about in there. Source IP address, destination IP address, port numbers, pointers to the various memory locations and where those are going to be. Transmission control block was open. Now, we can't send this HTTP GET message yet because we don't even know if the Google web server is alive at this point. So now we have to do the three-way handshake to find out if he's alive. So this is the process that happens. So the process that happens is TCP sends its very first segment. Now this segment does not have your HTTP inside of it. It's basically just a TCP header all by itself. There's no data behind it. It's an IP header followed by a TCP header, and that's it. And in the TCP header, in the control field, let's go back here. Let's just go back to this for just a second. Remember how the TCP header had the control flags that we see right here? Well, one of those control flags is called the SYN flag. It stands for synchronize, meaning I want to synchronize a session with you. This is my very first TCP segment. I'd like to synchronize with you. Synchronize like sequence numbers. There's another flag in here called the ACK flag. So now that we know that, let's go back to where we just were. Okay, so here we see this. So here we see this is our TCP segment going out, and it has the SYN bit set in the control flags. What's this X stand for? That's his initial sequence number. Right? Our TCP header has to have a sequence number in it. So this is going to be some random number. You can't predict what that's going to be, but it's going to be some random number. In this case, we're just saying it's X. So right now the sender is saying, hey, are you there? And by the way, this is going to be going to, if we were talking about HTTP, the destination port number in here will be 80. And we'll have an IP header in front of this. So this is the sender's way of saying, knock, 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 receiver, are you alive? If you are alive, are you listening to HTTP on port number 80? Can you let me know if you're there? That's the purpose of this initial first TCP segment. Now the receiver, if he is alive, has to respond to that. So he receives the SYN with sequence number X. He's going to generate his own SYN, because remember, the very first time I talk to you in this direction, I raise the SYN flag. And you only see that once. Now you and I might end up exchanging thousands or tens of thousands of TCP segments over the course of our talking, but the very first one I send to you, I'm going to raise the SYN flag. And the very first one you send to me, you're going to raise the SYN flag. After that, we'll lower that flag and we will never exchange the SYN flag ever again. So right here, this is the very first time the receiver is talking to the sender. So he generates his own SYN and he puts his own sequence number in there. So this is kind of interesting. Notice how there's a sequence number that started in this direction and there's another sequence number that starts in this direction. So this X is going to increment every single time something goes from left to right, and Y is going to increment every single time something goes from right to left. So notice that in this SYN, here the server, the receiver is saying, yep, I'm alive, I'm here, I acknowledge you. So in the acknowledgement packet, I put whatever your number was plus 1. So if the initial sequence number was, for example, 85, here he'll say 86, which means I'm acknowledging that I have received up to, but not including, 86. This is called forward explicit acknowledgments here, the way TCP does that. Okay, so the sender now knows that the receiver is alive. But just like the sender just got an acknowledgement of his sequence number, he needs to acknowledge the receiver sequence number. And this is the third part of the three-way handshake. He generates what's called an ACK. Now this is just another TCP segment. All three of these arrows here represent three distinct IP packets. Each IP packet has a TCP header with no data behind it. All we're doing is using the TCP header to raise and lower the SYN or ACK flags and to set sequence numbers. So at this point, because the sender has sent out this third thing right here, he goes into the established state. He says, okay, this is established. I'm ready to start sending data to the receiver. He can see me. I know he's there. He's acknowledged my sequence number. We're good to go. And as soon as this TCP segment gets all the way over to the receiver, and the receiver sees, oh, okay, he acknowledged my sequence number, now the receiver can go into the established state. And that is how the TCP three-way handshake works. Thank you for watching this video, and I hope you found it useful.